So how many of you knows observability in general? Yeah, so quite a bit. So when I arrived here, I said, "Oh shit, I have 50 minutes," and I didn't realize that. So I've added a few slides just for the introduction. So if you know observability, I will skip it because I think it doesn't matter for you. If you're okay with that, or you want to see those slides, you okay? All right. So then we're going to focus on the actual content, and we will try to have fun together. So let me remove those three slides. All right. All right. Are you ready for some fighting? Sure. I didn't hear anything. Sure. We need energy here. It's like boxing, you know? So in the back of the room, you can still have time to place your bets. There's two different fighters here. So I guess if you want to win some money, it's a very quick win. Just go there, put a bet on that, and you'll see that it's worth it. So let me introduce myself. My name is Henrik Rexed. I am a cloud native advocate at Dynatrace. So I've been working for Dynatrace about 3 years now. But prior to Dynatrace, I've been working as a performance engineer most of my career. Testing, breaking, tuning. At the end, you have fun, you know? What is the best of just destroying things? You not only destroy things, but at least you try to help projects. And that's why I'm still a big performance is still in my heart. I love performance. So that's why I'm still producing some content for a channel called PerfBytes for performance in general. And there's Almu here, who's also it's PerfByte Español as well. There's a PerfByte Français as well. So we're trying to increase the brand outside of the US. And so check it out. It's just content methodology about performance in general. And this content is basically a performance benchmark at the end. And then since 3 years, coming from the performance world, I said, okay, so let's jump into the observability world. And I was learning stuff, and I said, hey, why don't we create a YouTube channel? So this is why I created a second YouTube channel called Is It... there's a spelling mistake. Is It Observable with A, which is here is missing. So it's almost 3 years now that I'm producing content there. So check it out as well. To improve the content, you need to have feedback. So if you hate it, let me know. At least I will try to improve so that you can like it. All right. So before we start this presentation, I want to be clear. To prepare this talk, no birds and no telescope has been harmed. No violence has been placed on birds. I promise I was gentle with the area of the project. This presentation is not designed to blame any open source project. In the opposite, I'm a big fan of the Fluent Bit community. I love the founders of Calyptia. I am also very involved in the OpenTelemetry community as well. So the idea here is more about helping the community on picking the right agents related to the need, right? Again, when I delivered that talk in KubeCon, and I did the benchmark with Fluent Bit 2.0, and at KubeCon they released 3.0, and I say, shit. So I updated the tests, and I rerun the test again. So this content is updated related to the version 3 that is currently out there. And also, for those who's using Vector, so here I'm not doing anything about Vector, but on my YouTube channel I did a video about Vector, and I included some tests to see how Vector behaves between those two projects. And surprisingly, yeah, Vector is not so fast as it's been announced on the website. All right. So the idea here is, I don't know if you've been playing video games when you were a teenager or still video. Okay. So there's a game called Street Observability Fighter. It was very difficult to get that game when I was a kid, but I had a chance to get it. So the idea here is we're going to pick two players, two fighters, and I intentionally picked for you, those two fighters. So on the right corner, we have Ryu from the Fluent Bit dojo. So very well known and very popular in the logging space. He's been trained by his big brother Fluent D, built in Ruby, did a lot of great things, but then they decided to build a C agent, very more efficient, very quick, so a very good fighter. And then recently, with Fluent Bit 2.0, they introduced the support of metrics and the support of traces. So Fluent Bit is extending and providing, it's not only a log agent for water that was named in the past, it's now a telemetry agent. So this is going to be the fighter from the Fluent dojo. And on the left corner, we have Ken. Ken comes from the OpenTelemetry community. It has a lot of things, and one of the components that is heavily used by the industry is the OpenTelemetry Collector. Initially designed for traces, in fact, because traces were the first signal, so they were providing most of the feature related to traces. So then, of course, after the release of OpenTelemetry metrics, the collector supported metrics, and now with the support of logs, of course, they support logs. And in November or December, we should expect to have some features for profiling, because profiling is just out of the door. Keep watching it, because it's going to be amazing. All right, so what are you going to learn or get out of this session? So we're going to do some tests, we're going to look at the results, but before we compare the actual resource behavior of the agent, it's really important to understand the experience design. So when you're designing those pipelines, because remember, those agents relies on configuration files, and you will have to go through the process of building a pipeline. So there's obviously a different design experience, so we're going to walk through that experience. And then we're going to look specifically on the plugins that we may need, or we may usually need, when we deal with logs, with metrics and traces. So we're going to compare each agents on each of those signals. And once we have a clear understanding, we can jump into the results and figure out who is the best fighter for the telemetry aspects. And you will see that we will also give some few recommendations during the talk. Are you ready?
Yes.
Come on. Okay, so round one. Design. All right, round one, design. So, like I mentioned, those two agents, when you launch them, either in the bare metal environments or in Kubernetes, it's going to be through a config map, you're going to load a pipeline file. And that pipeline file is holding the entire logic of what the agent is going to actually achieve. So in this, those two agents, the terminology is a bit different. So if you look at Fluent Bit, you will first define what you're going to receive, and this is going to be named input plugin. And then, of course, those agents, usually they are designed for specific purposes. They are gateways. Usually you send logs or traces, metrics, whatever, to those agents, and then they pass it to another destination. But not only. What we want to do, usually, you get some raw data, which is not indexed. So we're going to parse and add or enrich the data to be able to add more context to the telemetry data. So then when it ends up in our backend, then the data is well indexed by magic. So the other thing we want to do is to drop things, because if it's empty records, it doesn't make sense to send an empty records to any backend of the world, because at the end you're going to pay for the storage of an empty record. So there are a few things we're going to do. So that's why in both in Fluent Bit, when you are going to process the data, they have two distinct plugins. One is called first the parser, because it's initially for logs, remember, and then we're going to filter. And last, once we have finished our job, we want to send it to our backend, and it's going to be named output plugins. In the collector, the terminology is a bit different. It's receivers. Obviously, I'm receiving some things. Then I'm going to process. So I'm going to have processor plugins. And last, once I've done the job, I can export with exporters. And then there is a connector. I will explain later what's the connector once we go deeper on these presentations. So that's why when you deal with those agents, there are always plugins, and those plugins will always end up in those buckets. So either input plugins, filter plugins, processors, whatever. In Fluent Bit 2.0, they introduced a pretty amazing feature, but it was quite surprising for those who's been designing Fluent Bit pipelines. They introduced the notion of processors. So what does that mean? It means that when I'm receiving something, at the same thread when I'm receiving, I can start doing things. And so processor doesn't mean processors with the OpenTelemetry world. It's another concept. Is I'm receiving, and instead of waiting to the next thread of the filter or parser to do things, I'm going to utilize the same thread and do some transformations. So then I'm more efficient at the end. And that's why you see here I can start input, and when I'm receiving already in the same thread, I can do already some filtering. So at the end, you're pre-massaging the data, and it's a way of being more aligned with the multi-thread architecture, and because it's C language based, it's super efficient. So that's the major difference, and you'll see that when it comes to metrics and traces, this piece in the middle doesn't make sense. It's going to be mainly from the processor perspective. So now if you look at the pipeline perspective, and here this is really related to Fluent Bit 3, because it was not true with Fluent Bit 2. So if we just start with the collector, if I receive metrics, traces, or logs, then I can process them. I have all the right plugins to do whatever I want with the data, and then I can export. So that's true for the OpenTelemetry Collector. In Fluent Bit, when it comes to logs, you have the old architecture, I would say, where I'm receiving some logs, and I can have some processors, by the way, but I will do some parsing, some filtering, and then I will go to output, and maybe on the output I'm going to do some final stuff with the processor. But when it comes to metrics and traces, there is no filter. There's no filter and parser plugin. The first parser is mainly for logs. So at the end, everything will be done by processors. So when you receive, you do things, and then you pass it to the exporter, and then before you send it to, I don't know, Dynatrace or New Relic, you do the final modification, and you send it to those backends. So when designing those pipelines, obviously you need a logic. So you don't have the if-then-else approach in those pipelines. There is a specific structure. And Fluent Bit has, since decades, this logic of tag. And tag was very, very powerful if you understood the concept of tags. So let's take an example. So here on the left, I'm going to receive some data from Kubelet. And on the right, I'm reading logs from Kubernetes files. So when I'm receiving those logs, so I know the source, I'm going to put a tag on that, which means on the logs, I will have Kubernetes tag, and on the left, you will have a kubelet tag. And then when I do the pipeline, I don't need to put any if then else. When I do some transformation, I say, oh, this is going to match only the data that has that tag. So then you don't have the if then else approach. You just do match Kubernetes will go through here. So it means that when you are receiving, Fluent Bit is adding an extra attribute in the data, and that the attribute we use to figure out what you're going to do with the data, how you're going to modify the data. So at the end, with a simple notion of tag, you can do super complex pipelines, but in a very small files. You don't need thousands of lines. Just with the tags, you can do amazing stuff. In the collector, this notion of tag doesn't exist, to be clear. So you can do as many pipelines as you want. And the major thing is that to make this approach of, oh, this is a log file from I don't know, kube system or from kube proxy, and I will do it I want to deal it differently. I don't have the options to do that. So the only way to do this is using a connector. A connector in the collector pipeline acts like a receiver and an exporter. So it's going to, I start with a receiver, I do some processor, and then I'm going to send it to the routing plugin. And the routing plugin will say, okay, if the content has this, then I'm going to trigger this pipeline. If the content has this, I'm going to trigger this pipeline. So it's like a switch. So then the other pipeline has, as an input plugin, will have the routing connector has a receiver. And at the end, with this notion of routing connector, you can do amazing pipelines and very, 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 very complex pipelines. But if you just look at the number of lines to do the same thing that you did in Fluent Bit, you end up with 5 or 6 times more lines just to do the same thing. In the structure of the pipeline, the Fluent Bit has this structure called, I think it's Tumble, the format of Tumble plugin. So the structure is that you have like a bracket here, upper bracket with input. So you'd say, oh, this is an input plugin. And then in the name of the plugin, in the inside of that section, you say name, and here you name which plugin you want to use. So here I'm using tail, I don't know if you see it. And then after that I'm using a filter, and it's going to be the Kubernetes plugin. So this is how you structure. And that is basically almost an heritage of Fluent D. That was pretty much the same structure. And since Fluent Bit 2, I was so happy because they changed it to that. YAML. And I know that all the room here, you are pretty much YAML lover. So I know that they fulfill your need. You fulfill your need, and you're very happy about that. So the difference is that here you have you have a structured file, so it's different. And then here you can see that since Fluent Bit, here in this section you have processors. So this is where I'm receiving in the tail plugin some stuff, and in the same thread I have some specific processor, and you can trigger them on that logic. So at the end, if you look at that pipeline, it's pretty much sequential. So you receive, and then I go to the next step, and then I go to the next step. So it's a very sequential approach. While the collector, the pipeline structure is a bit different. It's more like a declarative approach. I have some input, so I list them without having any logic. So I will use the file log receiver, I will use the Prometheus receiver, I will use OTLP receiver. So there's no connections between your declaration. You just list and configure your plugins one by one. You do the same thing for processors. So you configure them one by one, and then you do the same thing for the exporters. You configure one by one, and so on. And at the bottom section, you have these service sections, and this is where you're going to actually define your pipelines and the logic. So here in this pipeline, you can, I don't know if you see it well, but you have, you start with memory limiter in the processor, then you go to Kubernetes attribute processor, and then the batch processor, and then we jump into the exporters. So it's basically the logic is at the bottom, and you can have as many pipelines as you want. By default, you have logs, traces, and metrics, but you can have a log slash, I don't know, tests, log slash whatever, so you can have as many logs pipeline as you want. There's no limitations. So I would say that from the design perspective, I have a preference for Fluent Bit because it's more lightweight, and because when you design it, you already have this logic. But again, it doesn't matter. Both fulfills our needs. We can achieve very complicated structure pipelines. So I would say that in this round of the design, there's no clear winner. I think they're pretty much equal. So let's go to the next round, round 2. Oh, come on. Logging. Oh. All right, so logging. So what do you expect when you deal with logs? Well, when I deal with logs, I need to receive the common protocols where we're going to exchange logs. And for that, usually, they are pretty much standard. So I will maybe send logs from TCP, UDP, syslogs, of course, OpenTelemetry, because it's an open standard. I will probably have logs going through OpenTelemetry. I can also usually go send logs from a Kafka queue. So I may also use the Kafka plugin. And also something else, Fluent has been out there, and they have their own protocol called the Fluent Forwarder. So Fluent is also going to be a very important plugin for any type of log agents of the market. And of course, reading a file. I mean, what do you expect? So from a bare metal environment and from a Kubernetes environment. And if you look both plugins, the collector and Fluent Bit, of course, obviously the names of the plugins are slightly different. We don't care, but they have them. Of course, if you look technically on the OpenTelemetry contrib repo, You can say that, oh, the collector has 23 plugins. Wow. Yeah, but do I really need them? If I have the standard ones, I don't care. I mean, of course, they have specific plugins for specific cloud providers, but at the end, if you use the open standards, you don't need those plugins. Then, when you deal with the logs, I mentioned we're going to modify and you're going to treat the data. So you need to do specific actions. So what type of actions you expect from an agent dealing with logs? Of course, I need to be able to enrich the logs, and by doing this, I will probably gonna need some parsers, so be able to parse the logs, extract some extra fields, add it to the log content. If I'm using collecting logs from Kubernetes, I may want to add the Kubernetes metadata because there's so rich information. I need to contextualize my logs, my traces and metrics, so if I need to do that. I need to drop, because if there's logs that is empty or doesn't make sense, it's gonna cost for nothing, so I need to drop that. And also, any API of the market, which means any open observability backend of the market, has an API to send data, and they will put a rate limit, which makes sense. So I need to basically batch my content to make sure that I'm not going to reach that rate limit. So if you look at those, the needs that we need for logs, well, they both has the same stuff. They have Kubernetes. In fact, they have the ability to add the resources on the logs. They have the ability to parse the logs. They have the ability to batch. Then of course, the plugins are named a bit differently. But what is important is on the parsing side. Fluent Bit has been out there since many years. It has tons of features for parsing. I mean, it's very, very powerful. So regex, JSON, you can build your custom parser, you can build EULA scripts. They introduced the WASM recently. And if you look at the OpenTelemetry side, then they have built their own language called OTTL, so OpenTelemetry Transform Language, which is interesting and really good. There's some downsides when you design, but they will probably improve it in the future. I'm pretty sure about that. And how to parse it, you will use transform that relies on that language. So at the end, it's the same thing. The only thing I would say is that designing the pipeline with logs with the collector, especially if you have a lot of transformation to achieve, yeah, Fluent Bit will be easier. But anyway, when you design those pipelines, there's no debugging experience as of now. So you have to send the logs to std out. You do a small thing, you look at the std out, say, oh, I did the transformation, great. I do a next transformation, I do it. So it's very an iterative process. You don't do it continuously. Once you have done a robust pipeline, then you're good. But the first time you do it, the developing experience is pretty bad. So I may expect that in the future it will be improved, but yeah, that's for true for any agents of the market. So I think that's the thing. So in terms of design experience for logs, I think Fluent Bit, I have just for the parsing aspect is my preferences. But at the end, when feature-wise, I think both has the same features. I would say, depending on how much experience you have with one of the agents, I cannot tell you that Fluent Bit will be better because probably you will prefer the collector. So let's go to the next round, which is metrics. So round 3. Ah, that's better. All right, so metrics. What do you expect from a metric? All right, you don't know? No. We need to receive metrics. So they are obviously same thing to logs, common protocol to exchange logs. So collect D, stats D, OpenTelemetry because it's all the open standards. Prometheus, of course. If you're not supporting Prometheus, then you're not supporting most of the product of the market. And I may want also to collect metrics from a host, from the host where the agent is running. So there are specific plugins for Linux, Mac, Windows, and so on. The good news is that both agents has those plugins. So no problems of receiving the data. All right, next. What do you expect from the metrics? What do you want to do with the metrics? Well, if you're not aware, usually people think that metrics is the cheapest signals in the observability market. Do you agree? No. And the answer is no. And there's a reason behind. A metric is structured with labels. labels are great because, you know, when you send a metric, usually you add labels because you want to say, oh, I want to look at the CPU, split it by hosts. So host is a dimension. And so having the labels is awesome because at the end you can do a lot of analytics, you can do a lot of drill down. But there are some people who thinks that, oh, I'm going to add the version number, I'm going to add the date, the hour. I'm going to, I mean, sometimes you ask yourself, why did you create that label? But never mind. The problem is that when you have those labels, then the cost of the metric completely change. First of all, the number of labels is like it's exponential. The metric cost is like your one single data point in the time series database will be exponential 50 times, or if you have 50 dimensions. And the other aspect is the cardinality. So do you know what is cardinality means? It's basically the distribution. So if I have two labels, let's say I have the process ID and I have the name of the program. So name of the program, okay, maybe I have 50 programs. So it's not a big distribution, I'm good with it. But the process ID, I will probably have thousands of numbers behind the process ID. So it means that the distribution is just exploding and the cost of storage will be exploding. So look, when you look at labels, try to think, do I really need it? Would I do some statistics in the backend? Would that be useful for my needs? No, so let's do something. So that's why when you deal with metrics, I want to do precise actions. I want to first enrich, probably because in Kubernetes, if I don't have the metadata with the pod, the label, namespace, I'm going to add extra labels. You say, hey, you said that it's expensive. Yes, I know it's expensive, but if I don't have the right dimensions, I'm not able to contextualize my data. Then I need to drop, because of course, if I have some metrics, which is, you know, in Prometheus, there's always the _ go metrics at the beginning, which is basically the consumptions of the exporter. I think usually I drop it because I don't need it. So dropping those metrics, it will be also a way of saving some money here and there. And then, like I said, reducing the cardinality, dropping labels. This is a crucial feature that you need. And converting. You may say, what is conversion? Do you have an idea why you need convert? No? In the market, there's two formats of metrics. There is the cumulative, and there's the delta. Cumulative is all the things that are related and on the support of Prometheus. So that will mean Prometheus supports, as a backend, supports cumulative. That means that there is, I don't remember, Honeycomb, I think, is on cumulative, and I don't remember the other ones. But if you look at, I think New Relic is also cumulative. But in the other world, there's the statsd format, and statsd is delta. And who is supporting delta? Dynatrace, Datadog, Lightstep, and the rest I don't know. But depending on the backend, if you're collecting some metrics, you cannot send it straight forward to the backend because the backend says, I don't get it. So you will have to convert it. So this is why conversion is like a crucial feature. So if you look at those two agents, the collector obviously has everything. Check marks, good to go. Fluent Bit didn't have nothing until Fluent Bit 3, where they introduced first the metric selector. So metric selector is a way of, I don't need that, I'm going to drop it, I'm going to exclude this. So you have better control to filter the data. And then they introduced labels, which is not even in documentation. So you have to look at the code to understand. They will probably introduce on Fluent Bit 3, whatever. But labels is great because you can basically drop your labels. You can do already reducing cardinality. You can already place with some labels, and you can rename, but the feature of renaming labels is not working yet, so I expect that it will work soon. But it has those features, but the conversion is missing. So no way of converting. So which means if you collect metrics with Fluent Bit and you are going to send to the backend, it will only work if you scrap Prometheus metrics. With Delta, it supports cumulative. So that's one thing you have to keep in mind. The other thing is there's no way of enriching, so no way of adding Kubernetes metadata by default. So if the metric doesn't have it, then you will have to go through a collector. So, and then, like I said, no conversion, which is, I think it's I'm complaining with the community. I say, add the conversion, please, because otherwise people never use the metric support. So I would say for metrics, clearly for me, there is no questions. If you have to deal with metrics at high scale, with a lot of data, go for the collector. Go for the collector for the features that you need for your metrics. So, next round, round 4. Come on. So, what do we need as a plugin? Of course, we need to receive traces. The open standard is OpenTelemetry. It's a new format, so it makes sense. So we will have to support it. And then you have Kafka, because you can send the traces through Kafka, through Q. And then you have the ancestors, the dinosaurs of traces. So Zipkin, OpenCensus. There are still applications that are not OpenTelemetry friendly who still send their traces in those formats, so you still need those supports. So when it comes to traces, there was no question when I started the benchmark. I mean, OpenTelemetry has all the features we need, so they support everything. No question about that. Fluent Bit, it's only OpenTelemetry. And only OpenTelemetry on the HTTP protocol, which means if you're having anything sending through gRPC, yeah, you will have to find a way of converting the protocol on the way. Then what do you expect from a feature? So when you deal with the traces, you need, of course, to enrich your traces with extra metadata. And then you want to drop probably some traces that are unuseful, and you want to sample. So sampling, I'm pretty sure that you know what is sampling. Yeah. So sampling is very important because at the end, you never send 100% because people look at their billing and they're afraid about the cost of the traces. Usually, it's you need a number of samples. It's like you have a bag of marbles with 100 marbles, and then say, okay, I'm going to try to make some stats. So you say, I'm going to put 10%. So by in 1,000, a bag of 1,000, you pick, I'm going to pick 10. And then you look at the color. Oh, so now I know that there is 15% of red. Is this statistics really representative? No. So the sampling is also a really difficult job where you have to figure out how many samples do I need to make the right decisions. Do I need to focus only on the errors, or do I need also to so that's why you need some plugins. So that's why there is 2 types of sampling. There's the probability, head sampling and tail sampling. So there are plugins that will do head sampling, so at the front. And tail sampling is that you keep the entire trace, and then you say, based on rules, you say, oh, if there's an error, if the response time is that much, whatever, I'm going to keep it. The rest, I will drop it. So sampling is really important when you could deal with traces. And of course, as expected, the collector has everything. It will serve our needs, so no questions about that. On the Fluent Bit side, because they are pretty new on that aspect, and they're dealing the traces more like a JSON object, like a log, they can basically enrich the data with content modifier. And that's the only thing they can do. So for traces, no question. I think we all agree the collector is obviously the winner. It has everything that we need. All right, so now let's jump into the interesting numbers, which is the performance. So round 5. All right, so to achieve this, I had to do some benchmark. So I decided to do, okay, so I'm going to do different pipelines. Of course, I'm going to do pipelines for Fluent Bit. And then when I looked at the collector, I said, oh, I can do different things in collector. I can do processing upfront because the file log receiver has already, a file log receiver, if you are not aware, it's donated by ObserveIQ that has an agent called Stanza. And when they donated, Stanza was a full agents package, so they have all the feature, which means when you're dealing with a file log receiver, you can already process the logs. So there's 2 ways of doing. So should I do the processing at the file log receiver, or should I do the processing after with the processors? So I said, okay, maybe I'm going to add extra tests and see what's the best. So I did some, the logic is simple. I will do, so I have all those pipelines. So collecting logs with only Fluent Bit, collecting logs only with the collector, and processing at the receiver, and then after, and so on. And I will do first logs, then I will logs and traces, and then log traces and metrics. And I will do different tests to be able to achieve that. So the pipeline, because we saw, obviously you cannot compare with the same feature, so I had to reduce the scope to compare what is comparable. So with the logs, I say, okay, I'm going to receive the logs. I collect the logs on Kubernetes, and I'm going to reach the Kubernetes metadata. I'm going to add a few extra resources. I'm going to do some parsing, very limited, and then I'm going to export with OpenTelemetry. On the traces, I will just enrich because they have the content modifier, and I will export it. That's the only thing I'm doing. And then on the metrics, I'm going to scrap some Prometheus subdata, and I'm going to reduce the cardinality because Fluent Bit 3 supports that. And then I'm going to add a few labels with the label processor and export it to OpenTelemetry. So at the end, I was trying to use the same features. And one thing I've added, because we want to measure the behavior of those plugins, I enabled the telemetry. So both agents has, of course, observability data exposed in Prometheus format. So it will help us to figure out some numbers and how it reacts. So to achieve this, I had to design two distinct architecture. So here is, by the way, the repo if you want to play around on your environment. I had to design two different architecture. Why? Remember, Fluent Bit doesn't support gRPC. So I had to find a trick to modify on the fly the protocol to HTTP. So in this environment, I have how do I going to do the load test? I'm not going to send some fake data. I'm going to read actual logs from the cluster. And I'm going to use the OTel demo, which is an OpenTelemetry demo application, generating OpenTelemetry metrics and traces and everything. And I'm going to use the hipster shop. And I will have actual real load tests. And if I generate more load on against an application, there will be more logs produced, and there will be more traces produced, naturally. So that is the concept. And then to be able to collect the logs, I will have a Fluent Bit deployed as a daemon set to read the logs from the node. I will have Istio, because Istio will include Envoy everywhere, and it will add extra metrics and extra logs. And I've added intentionally, because Kepler, do you know the Kepler project? Yeah, I see if you had it, but I will remind. Kepler is an awesome project. It's deploy a daemon set with eBPF probes, and it will produce the energy consumptions of your pods, split it by namespaces, by tons of dimensions. So it's an amazing project, so you can estimate the consumptions and the carbon footprint and everything, but it's the most expensive exporter I've seen. Lots of cardinality, lots of things. So I want to figure out, okay, how those agents behave with this exporter that could be very intensive for the agents. And of course, I will have dynatrace because I have dynatrace. And so that's the Fluent Bit architecture. The collector has a slightly, sorry, I didn't mention. I have a stateful set deployments of a collector because OpenTelemetry demo is sending the traces to the collector just to do the switch of protocol to be able to send it back to Fluent Bit. That's the only reason why there is a collector here. In the collector, of course, simpler. I will have a daemon set to read the logs, and I have a stateful set, which I didn't add here, to receive the metrics and traces. And of course, the same thing. All right. Oh yeah. Before we start with the numbers, the approach was very simple. I will have 2 rounds of tests for each family of tests. I will have a ramp-up test, so 2 hours. I start with 50 users on each application, so hipster shop and OpenTelemetry demo. And every 30 minutes, I'm adding 50 users. So at the end of the test, I have 200 users on the hipster shop, 200 users on the OpenTelemetry demo. So that's how I'm having an increase of signals. And then I will do another round of tests, which is 50 user, constant, during 24 hours, just to see how those agents behave in memory, consumptions, and CPU. So let's look at the first test, which is logs during 2 hours. So you can see that I have the logs, the number of signals coming in. And then we can look at, I'm not going to compare the behavior of the receivers because the numbers will be the same thing. But I'm going to focus on the resource consumptions. So on the bottom here left is the CPU, here is the memory. And the blue line is the Fluent Bit. So it's consumed about 60 millicore, about that. The collector is about 80, 90 core, depending on the guy, because that's a daemon set. And then on the right side, you have the memory. So Fluent Bit is about 15 megs consumptions, and the collector was around 90 to 100 megs. So already just by looking at this, you say, okay, collector consume more memory. Again, it's a Go binary, and the other one is a C, so you may expect that. Now I added the traces, so you can see that now we can see the ramp up with the traces here. And if you look at the resources, well, it's the Fluent Bit is consuming a bit more, but still is consuming less than the collector in terms of CPU. And if you look at the memory, the Fluent Bit is super stable, still about almost 20 megs, and the collector is still at 100. Very stable, no impact during that test. And then I introduce the metrics. And then I look at the metrics. I say, okay, so everything is normal. I look at Fluent Bit. So here I'm about 100, 150 millicore. The collector starts to reach about 800 millicore at the end of the test. I say, okay. And then I look at the memory. 15 megs, 20 megs for Fluent Bit. And the collector starts to reach to 2.5 gigs. And I say, okay, I need to do a soak test. There is something behind. So I did the soak test 24 hours, 50 users, 24 hours, and then I looked at numbers. So here on the purple, the pink and gray graph is the collector. So at the end it reached about almost 2 cores. Crash, restart. But the most interesting piece is the memory. So it starts, reach about, intentionally I didn't put my limits because I don't want to leap. Come on, eat resources, to see how it behaves. And the collector reached about almost 10 gigs, crash, and restarts. And I say, that sounds like a memory leak somewhere. So I say, okay, so before alerting everyone, which I did, I said, guys, there's a memory leak on the collector, and this is only, I think it's only on the metric. And I will confirm that with some few tests. So I say, okay, let's figure out which signals is causing this, just to confirm. So I did the same one. Soak test with only logs, test with only logs and traces, and the collector is stable, nothing, doesn't move. I say, okay, so there is something with the metrics. And to continue before we move on, I did some p-profiles, so the ticket is still open. And what we discover is that it's the Prometheus receiver with the cumulative to delta, the problem with the memory leak. And also, you don't have the memory leak when you do Envoy. You don't have the memory leak when you have just OpenTelemetry. You don't have the memory leak with everything. You have the memory leak when you have Kepler. So when it's intensive cardinality, for some reason, the collector starts to have an issue. So there's still, the issue is still open. And also something I hope I have submitted a talk for KubeCon North America to do some recommendation, and we try to figure out the right settings from the Prometheus scrap, because you will see that it caused a lot of impact on the collector. So it's still open. We're still doing some investigation about it, but still there is a major problem. So I said, okay, so I want to continue that benchmark. I know there's a problem. How can I delegate the metric collections on the collector? Do you have an idea? No? No one? The target allocator. Who have ever heard of the target allocator here? I see someone? So the target allocator is a feature introduced by the OpenTelemetry operator. And it's, I think it's the best feature that the collector has, to be honest. And it's quite a shame that it's only on the operator. But let me explain how it works. So usually when you do the scrap config in your collector, it takes the scrap config, and then the collector do the scrap config and do reach out to the various endpoints and do what he has to achieve to collect the metrics. When you enable the target allocator, what it happens is that it takes the scrap config So you have the scrap config. And then it says, OK, I'm going to send it to another workload called the target allocator. And the target allocator will look at the scrap config and will create jobs in a Prometheus format. And at the end, every collector, so if you have 4 or 5 replica, he will split equally the number of jobs per collector. So one metric will only go to the same collector. And then the collector is not doing a scrap anymore. It says, give me my job. And then you just have to send an HTTP call to get the metrics. So at the end, the collector have nothing to do anymore. So I thought, OK, maybe by doing that target allocator, maybe I will save the problem that we've seen before. So let's test that. And another great feature is that the target allocator supports the Prometheus CRDs, which means if you have service monitor and pod monitor, I don't have to do metric pipeline anymore. I just deploy a pod monitor, I just deploy a service monitor, and then the collector by magic will grab it. So that is so great. Imagine if you deploy every day, there's guys deploying Prometheus exporters, and you say, hey, could you update the pipeline? I say, okay. Now you don't have it. You just say, hey, deploy the service monitor. You know, I have a great feature called target allocator. It will pick it by automatically. So in this architecture, I have a specific collector deployed in stateful set, because at that time, target allocator was only supported on stateful set and deployments, not in daemon set. So I was not able to use it in daemon sets. So that's why I had a specific collector just for metrics for the target allocator. So let's look at the behavior. Same tests, 24 hours, but with a target allocator. So now on the top right, left, it's the CPU. And here, you remember, we reach almost 2 cores. And here, it's about 100 to 200 cores. So no explosions of garbage collector in the Go runtime anymore. And then on a memory size, I have one collector with 400 megs, and the other one about 800 megs. So no problems with 10 gigs that we were talking about before. And then if you look at, say, okay, now, collector great, but I guess the target allocator is going to suffer. It's consuming 10 millicore. And the memory is 60 megs. So nothing. So at the end, if I just sum up, I'm going to use 3-4 collectors plus the target allocator. I consume less than if I were using on the collector. So just for a resource perspective, I'm saving money and energy. The last question is, where should I process? So I did some tests about that. At that time, there was no feature introduced by the OpenTelemetry community. There's a feature, I don't know if you know about it, there's an experimental feature that you need to enable it with a feature flag when you launch the collector, and your collector will produce traces. So then you know the time spent on the pipeline, so that's fantastic. But it didn't exist at that time, so I had to put some timestamps and then do the difference with to measure the time spent on each steps. So here, I have one pipeline, like I said, where I'm doing some processing and filtering with a file log receiver. And the other one is doing mainly everything on the transform processor, so parsing, enriching, and so on. So on the left, it's the file log, and on the right, it's transform. So maybe it's too small, but what I was surprised, I thought usually when the industry says, it says, always do that up front, which makes sense. And then here, in terms of resource usage, I had a very slight advantage using transform. So I was surprised about this. In the processing time, the time spent in the pipeline, at the end, it was the same. So no revolution, it was the same. But so I think there's no major conclusion about this type of tests. I will always say that if you have some data, try to filter and modify up front. It doesn't make sense to have a big agents that do everything because it will suffer. So if you can chain different collectors and try to do the transformation step by step, and then you will have you will sweat less when you have to manage those agents. So that will be my recommendation. So as a conclusion, I would say that from metrics, I think collectors, I love it. Traces, I love it. Logs, like I said, I have a preference for Fluent Bit. For the logs, I would say, just for the parsing perspective, I love the collector for that. And then from the resources, I mean, there's nothing to compare. Fluent Bit, when you compare a C agent compared to a Go agent, what do you expect? It's a C is going to be obviously less expensive in terms of CPU and memory. So the Fluent Bit it's just tremendous. I mean, I don't know if you've been aware, but Fluent Bit was initially designed at the moment where IoT was coming out, and they was thinking, oh, IoT is the new stuff, so we're going to build an agent for IoT devices. So that's how it's been built. And IoT, yeah, it's still there, but for some reason, there's another project called Kubernetes that is more popular. So now we use it in Kubernetes. So small teaser for my YouTube channel. So there is plenty of content. I have a more deep dive episode about those benchmark. I have an episode about more on the target allocator, on the metric conversions. Yeah, plenty of that. Again, like I said, it's out there. It's maybe not perfect for sure, but I need feedback to improve the content. So if you love it, love it. If you hate it, just let me know, so then I can adjust the content. All right, do you have any questions? If you are interested to figure out how vector behaves, I can answer that because I did the benchmark with vector as well.
As far as you know, in the Fluent Bit scope, do you think the community is working to make it to more better metrics or maybe go to traces or?
What I know is that Fluent Bit is, like I said, when I did that benchmark with Fluent Bit 3, there was nothing about the label processor. And I discovered when I looked at the code, and I said, oh, what is this? And then I started to look at it, and then try to learn how to use it by retro-engineering the code. They are actually working on a few use cases. And it's been a year that I'm trying to force them to use the metric conversion. The way Fluent Bit works, and I think it's like every open source project on the market, they are building features that make sense for customers. So if the customer doesn't ask for it, they will never build it. And Fluent Bit has been mainly used so far for logs, and they're still out there for logs. So the metric is quite new. But if everyone here now, today, let's do it together. If we open an issue together, maybe it will be there. And for traces, I didn't mention, but they have a SQL processor. I mean, I love it. It's like if you modify fields, you had to create, I'm modifying this field, then I'm modifying this field, then I modify this field. Now you do a query, and it will do everything in one line. So I think that is great. And I told them that, hey, you can use, if you are supporting group by and stuff, you can start to do analytics on traces just by doing a SQL query. So they are thinking about it. I don't know how far they will do it. But I think they want to provide more feature for traces. At the moment, they present themselves more like a gateway, like a proxy for traces, more than something else. Any other questions?
Well, on this final thought that you said, you would encourage people to use several.
I would say that for in an organization, if you just deal with logs, there is no question, use Fluent Bit, because it will be cheaper in terms of resource consumptions. And then if you start doing other signals, it doesn't make sense to have two skills with two technologies, because at the end you are adding more pressure to the person in charge of those pipelines. So I would say, yeah, go for the collector. But then you have to be aware of that metrics depending on how you scrape it, and also I didn't talk about tail sampling. If you do tail sampling in terms of memory, depending on the number of sampling that goes through the collector, it's going to be a nightmare. So there are a few things that you have to be cautious. But yeah, if you just deal with logs, I mean, no questions. Just use Fluent Bit. If you start with other signals, then collector will be a good choice. Any other questions? Did anyone did you bet on the collector or no? Yeah.
When you
No, because if I no, so what I did is I did some ramp-up tests, 50 user, 50 user, 50 users. I didn't picks, and if I have more load on the app, then the app is designed to say, oh, I have some order, I have a user connected. So if I have more users, I have more log produced. So this is how I didn't do peak tests where I have suddenly a big spike. I didn't do that because I could have done that. But again, it takes time to do that type of thing. And yeah, if you're interested, Vector is the agent for Datadog. It's designed in Ruby, and the results is that the consumption is closer to the collector, a bit lighter. And it's only supported metrics and logs, to be honest. And the design experience, I think, is quite interesting, to be honest. But yeah, still, if you have to deal with a high load of logs, Vector won't be comparable to Fluent Bit for sure. All right, if there's any other questions, thanks for your time. Thanks for being here.